We are living in a very, very unique period. What's unique about this industrial revolution is that we have three of the world's most powerful technologies coming together at once. High-performance computing, AI, and we're now adding quantum computing to the mix. We've never seen that before.
Specifically in the case of the quantum computing, we're able to process information using the quantum phenomena or effect, and especially information about how nature acts or how nature behaves.
By computing at the atomic level, we can now start to understand why things happen the way they do.
This is why chemistry could be considered as a sort of lower-hanging fruit. If you zoom into the molecular systems and the processes that are happening there, they are driven not by the classical mechanics phenomena, they are driven by the quantum phenomena, entanglement or superposition that they cannot easily reproduce with the classical computational tools, right? You need to take into account the correlations that happens between every single particle within the system, and every small change can impact the whole system. Classically, you would do it one by one, and that's why the computational cost explodes exponentially. So quantum is probably the most natural way to do this, right? You compute particles with the particles. You cannot dispute the impact that it can bring to the energy, to the life science, to the chemicals, and all the other areas that basically contribute to our everyday's life.
So in drug discovery, today, it takes at least a decade, if not 15 years, to bring a drug to market. It takes billions of dollars of investment, and there's a greater failure rate. And if we can understand DNA information, we can then start to understand the cause of disease rather than treating the symptoms.
People in the world look, researching how to better build new medicines, or to build new chemicals, or to create new energy sources, or to drive advances in fundamental problems in physics, such as superconductivity, to financial services and making them safer and more secure. They have a tool to advance what they love doing and what their mission is. It makes tomorrow and every other day following it different.
Once you get an insight there, you're going to have an idea in some new space that you never even had before.
I want to remind people that a lot of commercial discoveries start with something very scientific in nature.
Before Quantinuum, there was Cambridge Quantum Computing, which was founded in 2014 and later merged with Honeywell Quantum Solutions in 2021, forming Quantinuum. This merger brought together Honeywell's innovative quantum hardware and Cambridge Quantum software solutions under one roof. We have now assets and ability and capabilities to do things a little bit differently. That is part of our USP, and that is what's going to make us even more successful as we race towards building the world's best universal, fully fault-tolerant quantum computers.
Since inception, the transformation that we've witnessed has been nothing short of unbelievable. Today we have over 650 people spread across global locations.
So most people are surprised about how big our team is, and to operate at the scale we operate, we need a lot of people with a lot of diverse skills. So we're very, very much vertically integrated.
So Quantinuum is unique in the sense that it is a full stack company. And by that, I mean we have the hardware, we have the middleware, and we have these application layers in cybersecurity and chemistry and AI.
Our strategy is to accelerate the path from quantum capability to quantum advantage, commercializing end-to-end solutions in areas where quantum can create meaningful impact.
To make quantum computing accessible, programmable, and deployable in real-world environments. We're in this to win it. We're really in it to win it. We've been very fortunate to operate at this scale. We've built out an amazing set of facilities to go do what we need to go do around the world.
There's not a day that I don't look forward to coming into the office and working with the teams here, because ultimately we're working on something that is fundamentally transformational.
You know, our scientists and engineers have become very resilient.
I think the most exciting part of my job is to learn something new every day.
I like working on solving these hard problems. I think it's very exciting to solve these hard problems. I enjoy that quite a bit.
That's going to be really hard, but let's do it.
And that's part of what draws us in, is that excitement of trying to figure out the answer.
And our team comes from a very diverse background, from engineering to the physics, theoretical front, as well as the optics and other supporting infrastructure. So yeah, I think it's that collaborative culture that really gives us the edge in terms of the technology development.
It's been the ride of a lifetime.
So at Quantinuum, we're big on commitments. Commitments to ourselves and commitments to our customers and the industry at large.
I think one thing that all of us at this company can take a lot of pride in is that we do what we say we're going to do. As customers can come to us and they can expect high performance machines, high performance results, and they get it. It's really built and grounded in this culture, a culture of integrity and honesty, a culture of scientific discovery, a culture of trying to do our best to really challenge ourselves to overcome our own challenges.
Our customers who are taking a risk with change and going from classical computing to adding quantum computing into their infrastructure, it's important for them to have a partner they can trust. That is why we won the big deals, but more importantly, won the hearts and minds before we won the deals. We have been on a roadmap to build the world's first universal, fully fault-tolerant quantum computers at scale.
Right now we have a hardware roadmap published, we have clear ideas how the error correction will progress, we have capacities that we hope to achieve within the next few years regarding our machines and the development of a software and algorithms. And it helps a lot to have a full stack approach.
We offered our first computer in the cloud in 2020, and we've been offering quantum compute in the cloud since then. One of the advantages of cloud computing is we can continue to upgrade the systems here, offer them via the cloud so our customers can always get the latest and greatest quantum computing capabilities that we can offer. So we use what's called the QCCD architecture, which stands for
Quantum Charged
Coupled device.
Quantum Charged Coupled Device.
QCCD for short.
This was actually invented just up the road in Boulder, Colorado, about 20 years ago by Nobel Prize winner Dave Wineland. And at the time, it was a heavy push to say the best qubits are based on something already in nature.
There's a bunch of good reasons to work with atomic ions as qubits. One of them is that every single qubit is identical. It's just a property of single atoms that they don't have a history. You can excite them, you can tear them apart and put them back together. Every single barium atom is the same as every single other. Nature guarantees us that. That's what's oftentimes meant by calling it nature's qubit. And so you don't have necessarily a yield issue with trying to improve your engineering processes to make your qubits more identical. That's just a given for us. Another reason to use atomic ions as qubits is that they can naturally be really well isolated from the rest of the environment. Oftentimes we talk about quantum information being fragile. That's really a statement saying that any disturbance in the environment, any interaction of the qubit state with a stray gas particle or a cosmic ray acts like a measurement and causes the quantum information to degrade. By putting single atomic ions in a vacuum chamber, levitating above these ion traps, we can really remove a ton of environmental factors from interacting with the quantum information. And so that gives us really long coherence times and great ways to store and protect quantum information. And that's a key reason why we can get such high fidelity operations in our devices.
There's a lot of architectures that have what are called nearest neighbor coupling. So they're just talking to the qubits right to the left or right or to the front and back of them. And so if you want to talk to several qubits over, you have to play a little bit of a game of telephone. You have to tell the qubit next to you, who has to tell the qubit next to you, who has to tell the qubit next to you. Those are called logical swap gates. But every time you have that interaction, just like when you played that game of telephone when you were a kid, just when you have that interaction, there can be a little loss of fidelity. There can be a little loss of information. We don't have to do that. And the analogy of that is I just get up and walk to a site that's quiet and have the conversation. That's exactly what we do in the QCCD architecture. So they're not stationary. They're not in a large, long linear trap. They're actually moving around. And that has several advantages, but one is called all-to-all connectivity. Now that might sound like a small and easy thing, but it's not. Several architectures, many architectures for quantum computers can't do that. You have to maybe what I call daisy chain qubits together, or entangle multiple qubit pairs to get two different qubits located on the opposite side of the system. We can just physically move this qubit to this qubit and interact them. When you think about our chip, we're moving to an architecture where you can move the ions in a crisscross lattice. So you can think of downtown Manhattan.
An array of streets and avenues.
Where the most efficient way to route qubits around and avoid traffic jams.
Where each qubit can go left and right in parallel with other qubits. And it allows for the rearrangement of the qubits in a much, much shorter time.
We launched our first computer system model H1 in 2020 with only a few qubits, but continued to upgrade it over time.
It was a very simple design. The qubits were arranged in a line.
We launched our second quantum computer H2 in 2023, also have upgraded that over time.
H2, it's a racetrack, it's a circle or an oval.
Part of the story of Helios is that we are making a really big shift from H1 and H2.
So to go envision Dave Wineland's original concept of the QCCD architecture, we had to solve this corner problem. That is, how do you route these ions around this corner? We actually solved that problem several years ago and demonstrated that we could do that with very high fidelity.
And that research breakthrough really caused a rethinking of the kinds of architectures that we could realize.
And Helios incorporates this particular feature called a junction, just a single junction. And that's the proving point for our scalable architecture on Sol and beyond.
The junction is absolutely foundational to the next generations.
So we're moving to that architecture. We'll have a lot of these junctions. And now with that blueprint of Sol, you can just scale it up. You can continue to add more junctions. You can continue to add more qubits. You can continue to add more gate zones. And we can get many, many, many qubits on a single chip, on a single tile of that 2D array. Now, when you want to move beyond that, you can just start laying down the tiles of that 2D array. And you can actually move the qubits from one tile to the next. So that allows another lever for scaling.
I want Helios to be remembered as, the moment that we really transitioned into a world with useful quantum computers.
Helios for Quantinuum, but more importantly for our customers and the ecosystem and the world at large, is a dream come true. It has been constructed to be, for the first time, the machine that we can sell multiple copies of.
So we also deploy quantum computers to sites. Most recently, we deployed a quantum computer to a Riken laboratory just north of Tokyo. And that's been a great experience to get to be part of an ecosystem and grow that ecosystem. So we can offer quantum computing capabilities. We also, in that case, are doing hybrid compute with their supercomputer called Fugaku, which is really a storied supercomputer, one of the largest in the world. And then we grow that ecosystem with collaborations with researchers, collaborations with industry.
My background is the supercomputer. I was in charge of the development of the Fugaku in the hardware side. My project final goal is that to demonstrate the quantum advantage by combination of the Quantinuum, H2, and the supercomputer, the Fukaku. By the combination of a supercomputer and a quantum computer, you can solve the problem which cannot be solved by only using the supercomputer. So, because of the high fidelity of the Quantinuum, many people, many researchers in Japan is interested in using the Quantinuum machine. From drug discovery for the simulating of the biomolecules, and also quantum machine learning. So it's the variety of the application will be executed by using RayMay. I'm very impressed in the Quantinuum machine. And because of Quantinuum has good fidelities in a quantum bit, and also very flexible connection between the qubit or two-on connection. That machine is heavily used in scientific research.
We don't believe that quantum computing will replace classical computing. Rather, we envision a future where classical, AI, and quantum work in concert. When we launched Helios, we didn't just unveil the most accurate quantum computer in the world, we also launched a completely new software stack, one that's compatible with existing ecosystems, including platforms like NVIDIA Q2Q. So the software extends rather than competes with the established developer environments.
If you look at the software stack, it is in itself just as much of an innovation as the hardware is. It has the capabilities to make it easier for developers to use quantum error correction, experiment with it, integrate it with their applications, and make their applications more effective. For my partners and customers, our commitment is we're there with you. If you're a customer that has use cases, now is the time to get started.
We've spent the last decade in an age of discovery, hammering out the grand truths of our technology. We are now at the stage where we can engineer and scale our solutions into this era of acceleration.
We've come a long ways, but there's a long ways to go. It is deep tech, it is deep science, but this has never been a science project. Not everybody can operate at this scale, and this is what it's going to take to really be successful. And we've built this very powerful foundation
For clients and customers and researchers across the world to start to explore the hybrid classical quantum space. Many nation states now have multi-year programs centered around quantum computing as a technology. Understanding of the opportunity has increased, and we align ourselves with industry leaders who have the domain expertise and have significant problems to solve.
We partnered with Quantinuum because of their world-leading quantum hardware and software platforms. We are particularly focused on computational biology, materials discovery, quantum chemistry, finance, and optimization problems. The goal is not just to explore new science, but to deliver outcomes that benefit our economy and society.
Helios, a state-of-the-art quantum computer hosted at NSCC Singapore, will complement and augment our existing supercomputers. Working together, both technologies will open new possibilities for scientific and industrial breakthroughs that neither could achieve alone.
Our partnership with Quantinuum is a strategic collaboration that supports our national strategy and positions Singapore as a leading quantum computing hub by providing our researchers early access to one of the world's most advanced quantum systems, the Helios.
What you can do with quantum, you can simulate things on an atomic scale level, which is not possible with classical approaches. Basically, if you have more than a few dozens of particles, complexity will explode, cost will explode, and accuracy will decrease. We have the problem we have and translate it into the quantum world, and this is where Quantinuum really can help us. We are simulating the fuel cell reaction. Basically what you have is the reduction of oxygen using a catalyst like platinum. And of course this is expensive. And by simulating it and optimizing it, optimizing the amount of material of platinum you need, you can really reduce cost and you improve sustainability as well. So what I like about Quantinuum, they have a very holistic approach. You have a very performant team as well. And you have a plan for the future. That's what I like about it. So this is good for us. And I'm pretty thrilled that getting a real world application with Quantinuum is not too far away. That's what I suppose.
We hope to build a quantum industry from Japan and expand it globally as part of the future infrastructure for data center for AI. This shows our effort to use future technology to solve today's problem.
Our customers came to us and said, we have these amazing ideas to try. That is the most exciting part about Helios. That's the most exciting and rewarding part about being in this business. And that is surely the most gratifying part of being Quantinuum. That is why we exist. We exist to transform the experience for humanity for the good, to make the world a better place.